Hello everyone. The topic for today is sets. Let's have a look at the definition. Set is a collection of elements. For example, A has the following elements 1, 2, 3 and 4. Therefore, A is a set of the first 4 natural numbers. B has the following elements 1, 4, 9, 25 and so on in the series. Therefore, B is a set of squares of all natural numbers. Next comes operations on sets. Just as addition, subtraction, division and multiplication are operations on numbers, we have the following operations on sets. Let's have a look at the first operation, which is called the union. It's also written as AUB. Consider the following sets. A is equal to 2, 3, 4 and 5 and B is equal to 1, 2, 6, 7. Now A union B is equal to 1, 2, 3, 4, 5, 6 and 7, which means A union B is the collection of all the elements, repeated elements appearing only once. We also have a diagram called the Venn diagram, which will help us to understand the concept of union of sets. Now, in this diagram, we have two circles, circle A and circle B, which represents the two sets, set A and set B respectively, and the area shaded in red represents the union of these two sets. The second operation is called intersection, which is also written as A inverted U B. To understand this concept, consider the following sets. A has values 1, 3, 5, 7 and B has values 2, 3, 5 and 6. Now A intersection B is equal to 3, 5, which means the two values that are common in both the sets. Therefore, A intersection B is a set of all the common elements. As seen in the Venn diagram, the purple shaded area represents A intersection B. The third operation is called set difference, which is also written as A minus B. Consider the following sets now. A has elements A, B, C, D and set B has elements B, D, E, F. Now, A minus B is a set of elements of A which are not in B, and B minus A is a set of elements of B which are not in A. In other words, A minus B in this case would be A and C, because A and C are the only values from A which are not present in set B, and B minus A would be E and F, because E and F are the only elements of B that are not present in A. There are two Venn diagrams here. The first one shows the shaded region A minus B, which of course will have all the elements of A that are not present in B, and the second figure shows B minus A, and the shaded region will of course have all the elements of B which are not present in A. The last operation is called the Cartesian product, which is also written as A into B. Consider the following sets. A has elements 2, 3 and 4 and set B has elements 3, 5 and 7. Now, A into B will be a set of ordered pairs. In order to multiply these two sets, each of the element of A will get multiplied by the other elements present in B. So, A into B would be 2, 3, 2, 5, 2, 7, 3, 3, 3, 5, 3, 7, 4, 3, 4, 5 and 4, 7. We've taken 2 from set A and we've multiplied it with all the three values of set B. One very important point to remember in this is, if set A has m number of elements and set B has n number of elements, then A into B will have m into n elements. Next comes set algebra. To understand this concept, we'll derive a formula, and to start with, consider the following sets. A, which has elements 1, 2, 3 and 4, and set B that has elements 3, 4, 5 and 6. Now, NA would represent the number of elements in set A, and in this case NA would be 4 because there are 4 elements in set A. NB would represent number of elements in set B, and in this case NB would be 4 because there are 4 elements in set B. N A intersection B would represent the number of elements in A intersection B, and in this case A intersection B is 3 and 4 because 3 and 4 are the common elements in A and B, and hence N A intersection B would be 2 because there are 2 elements in A intersection B. N A union B would represent the number of elements in A union B, and in this case A union B is 1, 2, 3, 4, 5, 6. Therefore, N A union B is 6 because there are 6 number of elements in A union B. Now, NA plus NB minus NA intersection B is equal to 4 plus 4 minus 2, which is 6, which is also same as NA union B. Now there are two important formulas that you need to remember while solving questions from sets. Formula number 1 is NA union B is equal to NA plus NB minus NA intersection B, which we just proved using an example. Formula number 2, when there are 3 sets, NA union B union C is equal to NA plus NB plus NC minus NA intersection B minus NB intersection C minus NC intersection A plus NA intersection B intersection C.